Hi there, thanks for watching. Today I'm going to use JavaScript to recreate one of these. This is a delay pedal that you'd use to connect a guitar to an amplifier to add some kind of delay effect to it. And I'm going to recreate that functionality in the browser. So this is our browser here. And let's get started. The thing that we really want to look at first is the audio context. This is a way of it's kind of a gateway into the audio power of the browser. By creating a new audio context object, which in this instance we're just going to call context, we then have that variable that we can use to create audio, to connect bits of audio creating things to audio listening things. We can do all of that kind of stuff using this context. And of course, because we live in the real world, we need to kind of slightly fudge things a little to make sure that it works in all different browsers. But once we've got that audio context set up, we can then start using it. And the way that we're going to use it is to basically recreate the idea of a signal path. Signal path is part of like how a band set up on stage works. It's the path that sound takes to go from, say, the instrument to the mixing desk and then out to the speakers so that we can hear it. And in the context of the audio context, that looks a bit like this. So the instrument will become an oscillator. We'll be using an oscillator to create some sounds. The mixer will become a gain node, which is a way of us controlling the level of that signal, the volume, if you will. And the speakers will become our context.destination. And so to work backwards through this path in more detail, the context.destination is available on that context object that we just created. And the destination will be either the speakers in your laptop or headphones or some kind of Bluetooth connection. Wherever your sound goes out of your computer, that'll be your context destination. And that's available by accessing context.destination on that context object. The gain node is a little bit more complicated. So we said that's a way of controlling sort of the volume of our signal. So we use that context again to create a gain node that we're going to call master. And then we need to set a value on that. And that's so the sound comes in at a raw level, essentially. If it comes from an oscillator or an instrument, it's just coming in at the level it is. We don't have any say over that. But once it gets to a gain node, we can then determine what level we want that signal to be. And the range runs from 0 to 1, so here we've got 0.8. So we're just sort of slightly less than full volume we're adding to this. And then you can see on the last line here, we're connecting that to our destination. So that's the output of the sound. So we've got the sound coming in, we're setting that volume level with this gain node, and then connecting it with .connect, which is a method on all sorts of audio objects that we create from our context. Notice that, of course, we're creating the gain node itself with create gain on the context on the first line there. So moving to the very start of that signal path, where the sound actually comes from, we're going to simulate a voltage controlled oscillator. Of course, it's not voltage controlled because we're not in the analog world. We're not actually plugging electricity into things and wiring things up and soldering them. But we can simulate a voltage controlled oscillator with the context's create oscillator function. So we call that, and that creates an oscillator object that we can do. And that has a frequency, which of course has a value, and we can set that value. So here we're setting a value of 440, which is in hertz, and that's essentially middle A on any kind of orchestral setup. That's the note, the pitch value of the note that we want. And then we're connecting that to master. And you remember that master was our gain node, which we're sort of treating as our master volume, which then obviously sends off to the destination. And now that we've created that oscillator, we can sort of test that it's working really using two pretty simple methods, start and stop, that pretty much do what they say. So if we click the button, we're calling start. You can hear that horrible noise, so I'll press it again to stop. And let's have a quick look at what we're actually dealing with here. So if we look at the frequency graph of what's happening, you can see when we start the pitch, we get a peak at 440 hertz, which is the A that we're after. And let's stop that now. I think what we will probably ought to do is soften this slightly so that it's not quite such a jarring sound. And this gives us a constant tone if we want it, which is not massively useful for sort of adding a delay to, because we just start layering that up. You're not really going to be able to hear what's going on. What will be more useful for us is to have something like a pulse. So let's look at how to have the button trigger a pulse of sound. So now when we hit start, we're not just calling start with no parameters, we're calling it with our current time. And then straight away we call the stop function, but we call that with a different time. So it will know to start and stop at these given times. And we're getting time from our context. Current time is one of the values in there, and that's a more reliable way of getting an audio signal than it is through like using a set timeout like you would normally in JavaScript if you were sort of timing things. Audio context has its own internal clock, which is much more precise. So now we're calling, basically, going to say we want a pulse of sound to last for about 0.25 seconds time. There we go. That was all right, wasn't it? Yeah. It's still a little bit kind of sudden. It's just on and off. So what we want to do is have a way of sort of ramping up to the volume and then ramping that down again, rather than just being on like that. We want it to kind of fade in and fade out. So we can use another gain node. We've already used a gain node for our master volume, but now we're using a gain node that's paired just to our oscillator. So I'm going to just create a simple JavaScript object here. We call it note, and we'll have voltage controlled oscillator and a voltage controlled amplitude is what we're going to have here, which is going to be a gain node. So we've got the oscillator and the gain node. We connect those two together, and then we can set the values by a thing called a function called exponential ramp to value at time, which, surprise surprise, exponentially ramps to a value at a given time. So we say we want to ramp up to the value of 1, so maximum volume, and we want that to take sort of 0.2 of a second. And then when we stop, we want to ramp all the way down to nothing, and we want to do that at kind of half a second later. So let's see what that sounds like. Now you see that's starting to sound a little bit more sonorous. We've got a kind of a gentle, it more closely mimics a sound that we'd hear in the real world, rather than the artificial just on-off of the bare oscillator. And now we can spice things up a little by making a little random number generator, which is on that get random int. All that's doing is creating a random integer between 220 and 880. So they're kind of the kind of range of sounds that we want to hear. So every time we press now, we'll hear a random pitch. Yeah, see, we talked about it being a bit more sonorous there. Because it's random, there's no sense of musicality in there. So we need to kind of enhance this a little bit. So here I've got an array of note values that have like their name, so that we know kind of roughly what we're dealing with, and the actual value, which is the important part. Lots of different pitches for all the notes in a C major scale. So now we can use that same random number generator, but we use it to generate the key for that array of the value that we want, and then we use that note value basically to create the note. So now we're randomly creating notes, but they're within the bounds of a C major scale, which should in theory sound a little bit nicer. Yeah, it's still a bit random, but it is within the bounds of a normal scale, so it sounds like kind of how we'd expect something, maybe music perhaps, to sound. And now we've got some random notes being generated. Let's get a bit fancy with it as well, and let's duplicate them. So now we're going to create a second voltage controlled oscillator, and we're going to change the frequency of that to be, I don't know, we can use a transpose function, which will take in frequency and then the number of sort of steps musically in either direction that we want to go. So say you're going from a C and you want to go to a D, that's sort of 2 semitones, musical steps up. So what the transpose function here does is actually works that out for us, like how much we want to like mathematically transform. And it's basically multiplying by a power law, the frequency. Let's double up our note value that we're getting when we hit pulse, and that second oscillator, let's have that be 7 steps up, so a fifth in musical terminology. So, yeah, 12 steps, but 8 notes, so 5 notes up the scale, and that sounds like this. You hear there, you can see on the scale, you can see on the frequency graph that we're getting the double peak of 2 notes being played at the same time. Of course, you can hear it. But because they're at the same time, it might be hard to pick out. So let's get on to the business at hand of actually adding in our effects unit. This is a little unit that will kind of sit into our signal path and add an effect onto that signal. So the normal signal path we've already established is instrument, mixer, speaker. This is how the effects loop sits into that. It's a little module that sort of takes a bit of the signal, does something to it, and then sends that signal back up to the mixer along with the original signal itself. Let's just focus on very basic representation of the pedal that we want to work with. So let's make that happen now. So we're going to create a delay object in our JavaScript. And that's nice and easy to do because the audio context has the concept of delay built into it. So we can say context.createDelay, and boom, we've got a delay node. And if we set the delay time value of that, that says how much time it wants to delay the signal before sending it on again. So anything that we connect to that delay will then slow down, well, won't slow it down, but it will pause the signal for a moment, which is the value that we've set, and then send it on to the master output in parallel. And let's see what that actually sounds like in real life. There we go. Well, we've got a delay, but it's only one. It's only doing it a single time. So let's look at what we're missing. And what we're missing is the idea of feedback. Feedback is the mechanism at which a small part of that delayed signal is fed back into the delay module. So it's feeding back on itself to kind of infinitely continue. And if we set the value of that to 1, then we're putting all of that signal back in, it would be an infinite loop. So let's not do that because that would sound awful. What we're going to do is we're going to create a gain node. We've used a lot of gain nodes so far. We're pretty familiar with them at this point. And we're just going to give it a very small value. So here we're going to say 0.3. So that's basically saying like 30% of that signal we want to send back in again. We're connecting the delay to the feedback gain node. We're then connecting the feedback gain node to the delay. So we're making that little loop. And you can see why now we don't want a value of 1 because that would just amplify forever. And then, of course, connecting delay to the master output again. And that sounds a bit like this. See, based on the amount of signal that we're passing back in, controls how many times we hear that delay. That's what that results in. That's the audible result of that action. And I'm going to add a little bit of a filter, which we're not going to get into in detail here, but what that is doing is sort of taking off some of the frequencies that we don't want to make that sound a little nicer. But we'll continue now and put those into slidable values. So the duration and the feedback are the two aspects that we're controlling here, and we can change them around. So we want our feedback to be really high. It keeps on repeating quite a long time. Shorten that up a little, but let's make the duration really long. Let's say we want it to be a whole second between pulse. And what we've done is essentially recreate the two main buttons on here. So we've got the master volume control, which is set by the master gain node. We've got here the feedback level that we can control. And then here, this one here is the delay time. So these two buttons here, these two pots here are the feedback and the duration, which is exactly what we've got here. I mean, this one actually has some presets on the end, but really, with the volume, the delay, and the feedback, we've got the setup that we're after. So we can now play around with that a little bit, have some fun, but kind of set to some arbitrary values. And we've got a delay unit that we can use to essentially create some kind of ambient music here. So let's have a look. And sort of take this out of the scenario where we've got our randomly generated notes of the C major scale and start plugging in some actual music, and this could start sounding really nice. So hopefully what this has done is show you some of the power of the audio context as it exists in the browser. We've just scratched the surface. This is pretty simple stuff, creating sounds and just manipulating it in small ways. But there is no end to the amount of creativity that can be had from playing with these tools. So hopefully this has inspired you to do something of the same. And yeah, if you've enjoyed this or you have questions, please do comment below. Let me know. Let me know if you've done something crazy with the audio context. I'd love to see what you've come up with. Thanks for watching.